Hello, it's Arthur from Artistry of Code podcast. Welcome to episode number 14. This time we have brought 3 examples of real-life data consistency problems that we needed to solve. If you're interested in how you dealt with them, just stay with us, relax, and listen. Here we go.
Welcome to the Artistry of Code podcast, where we, together with our guests, are seeking ways of doing things right and having fun with it.
Software, architecture, soft skills, teamwork, and other crazy buzzwords.
Are you ready? Let's bring more value to the business. Hello, it's Artistry of Code again. We came back from our vacations after about a month of not being here. We gathered in our original squad, so with Grzegorz, Marek, and myself. And so, guys, how did you spend your vacations? Tell us.
Yeah, I won't surprise you, but this is about the second part of my holiday time, let's say. But yeah, I've spent lovely 2 weeks on the Polish sea coast, and it was lovely family time with my wife and kids, and I was like super happy, and I cleared my head through this time. Yeah, and recently, even if while I'm working already, I'm finishing the house before moving in. So I have great challenge of setting up the a large network setup. But fingers crossed it will all go good. But I'm super excited. I always dreamed about like having proper switch at home with PoE, etc. So I'm like super happy to
So
to
it
do that.
sounds like traditional Polish vacation time. Just
Yeah, exactly.
doing
Workation.
something in your home.
Yeah, workation. Yeah,
That's true.
have vacation and work.
I will jump in here because I also spend my time on the Polish seaside. In my case, I went with 2 other families that actually were, we all were parents of 3 of kindergarten friends. So my daughter and 2 of her friends. We went to Weba. It was quite a nice time, but I wouldn't say that vacation with children is a way to get some rest. Maybe a little bit of reset of the head, because the circumstances are a little bit different. But with children, even though they love each other, it's always a struggle. There are always fights. They usually cry more when they are together than when they are separate. But I feel like it was a very valuable time. The weather was not perfect, typical for our seaside. But I'm back, and now it's it's warm again. So not the perfect situation, but yeah, with the new energy, I came back. And Grzegorz, when I was on this vacation time, I reminded myself the words of your own, that on the first day of your vacations, a year ago, you all raised the glass, just to say, okay, let's not let's not let's be friends still after those vacations. And this feeling helped me a lot, so thank you very much.
Yeah,
And tell
that
us what
toast.
you have done.
Yeah, that toast made by my friend when we went to Croatia. We also went in like 3 families, and yeah, the wish at the toast was to remain in a good relationship even after this trip. But then we were living for 2 weeks together in a single home. So yeah, I'm having some bad memories and good memories about that time, and we are still friends. So I must say that the spell worked just fine. So
Mission accomplished.
at least when it comes to to us. When it comes to my vacation, well, I was on vacation when we were doing the episode with Pierre. So since then, I pretty much didn't took any time off. Although, since we had like a small break from podcasting, and it's really good to be back, I took the time to finish off my sports season. So I was having my last triathlon race nearby Wrocław. So I focused heavily on getting prepared just to be able to finish it. I'm not racing for the awards, but we had like a very nice family time. And there I took the whole family. My both sisters came in also to cheer me up. So having those cheers helped quite a lot in the whole race. So yeah, that's how I spent the vacation time, like sports wise. Coding wise, yeah, I'm progressing with my like side project, really, and I'm really happy that I've made the decision to integrate Auth0 as a way to deal with users, because I have this done already in terms of I don't have to build up the authentication myself. And there's a nice library for React. So you just do an npm install and then you're ready to go with doing, like user logins, stuff like that. And also there's a lib for backend. So I had in below 1 hour, I had a full authentication cycle with Google sign on, right? So I'm just having this done already, and I can focus on the business logic. So I'm really happy about this. I had some free time, from my work, not related to vacation. I've just spent it on the side project, and this is how I recover from work, doing side projects. So yeah.
Grzegorz, if you have another spare hour, just try out Fronteg. Did you know that Fronteg is a competitor for Auth0?
Oh, really?
Yeah, it is. I recommend.
I'm sure you do. So the thing is that at least for now, the integration is so thin that it's easy to replace this. So I didn't
Try
do
it out.
integrate. Yeah. So right now I'm just using a single, let's say, information from that OAuth token, which is easy to, like pivot from later on. If I would like to change the auth solution, which I might consider, Arthur, then
Which is never easy, really, switching the
it's never easy
authentication.
later. At this stage, when I'm building an MVP, that's like super easy. Later is going to be difficult.
Yeah. As long as you have 0 users, excluding yourself, it's easy.
Yeah, your mother and your wife. Yeah. So thank you for your recommendation, Arthur. I will carefully consider.
It was right at the time. Now is also the time to carry on with our topic, which is consistency in the software. So today we will try not to be too much theoretical, but rather bring some experiences of our own and some real use cases that we have spotted in our career. And I know, Marek, that you have some quite interesting example of eventual consistency in the security IoT system. Can you refer a little bit?
Yeah, I can. This example maybe is not like super rocket science, but it was like already like 5 years ago. And then I won't lie, myself and guys which I was working with at that point, we were like starting with the microservices, and even at that time in general in industry, the whole industry was still learning the microservices. Everyone was publishing their thoughts, and you couldn't know which approach is really good, etc. Until you try and fail, and repeat with better choice this time. And we were building the IoT system, which was typical, let's say, IoT system with bulbs, switches, and sensors. Let's say some like typical home IoT, but it has the security security component in as let's say paid add-on for the customers when they could use their sensors to trigger the alarm, and they could lock the house, unlock the house, and also like in case of the alarm event, the system was supposed to call the security. I mean, virtually call the security through the lovely TCP socket interface, which was like super old, but it was like the stable solution which worked for many years. So that's why they didn't touch it. If it works, don't touch it. That's the old rule, which we all know. And we came to the point when we had to fix when we had to like implement the calling system, let's say. And at the beginning we went like straightforward, and we used there was an alarm event interpreted, let's say, by the alarm domain, because it was like listening to the IoT events in this whole system on the event bus, and like picking up only interesting events for this domain. It had to call the security with the user data, let's say, when the installation maybe data, not the user, but the home data. And at the beginning we designed it like easy peasy, and when there is an event, let's fetch the data from the user the installation service and use this data. Okay, it's fine, yeah. But then after some deployment, we were testing the service, and then boom, there is alarm event, but nothing is happening. Come on, why we don't have the security call? And then we came across this issue, and we couldn't rely on the data from the other service because it was down, yeah. And the approach, like having the strong consistency with that service, couldn't be used at that point, because it was like introducing the risk. It was super consistent, yeah, because the data was always up to date, but it was completely unreliable, which for security couldn't be the case. And then we were like switch the approach, like to try to use the service, but always through all the time build the cache in the service based on the events in the system about the installation data. But use it only in case of the failure of the other service. Yes, so it was like in good case it was like strong, consistent, completely consistent in this case. But when there was some issue, it wasn't super consistent. Maybe at least maybe if the event based system was working, it should be. But could be like, I don't know, some delay. But in most cases, it would still work even with the failure of the other system, because there was the cache which the service could fail over to and still call the security, which is much better than waiting until someone will push the fix to the user service and the service will come back. Yeah, so that was like probably the first like big challenge about the consistency between the services in the a bit bigger distributed system.
So what was the main problem of eventual consistency implemented in the first way? You just didn't try it at all, or?
No, we thought about the eventual consistency at the beginning, before we made the decision. But it was like, okay, so the data has to be like fully correct, because this is the alarm. So we cannot risk that the security will be called to other house, yeah? Because they will get the intervention at the wrong place, yeah. And we didn't really spend the time to think about it like much more. Okay, it's security, it has to be strong, consistent, done, let's go, yeah. until the first issue arose pretty quickly, and then we knew. Luckily, it was captured during the testing phase, yeah, because during in the production, it wouldn't be that fun. But that was like some challenge.
So Marek, one of the guidelines which I recall for doing microservices in that example, and I'm looking for an alternative to that implementation. Do you think that given those problems, the boundaries or the responsibilities of those microservices could have been outlined better? I mean, the bounded context, perhaps. I think that they are, because of they are right now separated, they allowed this inconsistency, right? And when the things should be consistent, then they probably should be within the same microservice, like end to end. So what would you say to that?
I would say we were considering like the boundaries there, and we didn't merge those services into the one context, mostly because both domains were like super complex already, and like merging them would be like super hard, and also the security service, let's say alarm service, whatever, it was like developed completely separately from the installation service, which is super great and advertised benefit of the microservices. Yeah, but it was really the case in this situation. So the cost of like having the cache and the fallback was like acceptable based on the big picture of this system, let's say.
Okay, so you essentially had some like organizational or architectural drivers which forced this design.
Yeah.
And by I'm just trying to refer to the DDD way of doing things, the context mapping. So how those contexts interoperate. This is determined by the like a customer supplier way, right? So if something was developed physically by another team, possibly in another company, then these kind of integration patterns make a lot of sense. Yeah, that's a very interesting case, because to me this sounds like quite an unusual way of dealing with that, because you're kind of like building a backup storage at your end, just in case the other party is not operational, right? Typically people advise, okay, let's do a circuit breaker and fail fast. But that wasn't an option, right? Because you want to have that alarm raised, so you just couldn't go for a circuit breaker and finish the job.
Yeah, there's a security event at your home, 500. Yeah, that's it. Done.
Okay, I got a little bit confused. So the event that you're saying that could be misinterpreted to be targeted to a different place in the world was coming not from the system, but from the backend system, but from the devices installed in the house.
Yeah, let's say to give an example, if you had like window sensors at home. And the alarm service knew that the installation 123 is now armed. So when the events about the Windows sensors were obviously point of interest for this service, were coming in for this installation, and that like let's say we were checking the ID of the installation. It's armed. Okay, let's do something with that. And then when we decided that based on the multiple if statements, let's say, that the alarm has to be triggered, we had to like get the data of the of this 123 house and send it to the security service. Yeah, I mean by security service I mean the real security guys. Yeah, not the microservice. And the risk here, which at the beginning pushed us to the completely strong consistency, like looking for the data right at the time of the call, was that we need to get the address of the installation, because installation can be moved, as people are moving houses. And that's the risk of like having a bit elastic consistency here in case of the failure, is that like someone could update the house location a minute before break and then we didn't have the chance to get the data updated. But if you think about the real situation, it's not likely to happen, because when someone is moving the house, the alarm won't happen that soon. Yes, so it's like if you think about the big picture, it's like not big risk.
So just to get the wording correct, so you don't mean people moving houses, but moving that alarm equipment from house to house, or moving themselves between houses together with the alarm equipment.
Yeah.
Okay, so you're taking off the sensors of the windows, and then you just
unless you are on the camper, this would be much trickier situation.
Yeah,
but,
that's actually quite an interesting case. I must say.
I don't think it's possible because you need physical address to like get the contract.
I just want to quickly mention here, because that's a super interesting case. I just learned about this, that as we were coming from Fissman and the IoT context, there is that I just recently learned that in Austria there are campers which are having Fissman's equipment installed inside, heating appliances. So essentially, these installations are having movable addresses. They don't have a particular address. So the concept of address as a place is no longer like a fixed thing in the domain, because you have your equipment in campers which are moving around the country. So it's super interesting.
As long as let's in this case security contract allows it, because if that's a matter of the contract, the paper or even electronic contract, it won't work. But that's really
that's
interesting
nice.
case.
If you have like security guards dispersed across the country, and then the closest security guard is going to secure a camper just in case of an alarm.
Maybe that's a good idea for the security startup.
I think we need to have a company now.
We already have a name.
Of security.
Okay, why I digged so much for this information is because when you, Grzegorz, were mentioning the bounded context in the domain, I also thought that this concept of bounding context and embedding the data into the event, so other services will not need to query other services to interpret it, is also a matter of good planning. And of course there were some reasons to do these decisions. But there's always I feel like there's always a way to consider where the data should lie. Which part of the system should be an owner of the data. And in this case, I feel like the concurrent idea might be to for example, have the installation to determine when it's located, using the GPS, using the pre-configured data, just like we do configure it, for example, in the Home Assistant, which we both, me and Marek, know that you need to configure the location. It's rather this way than based on some contract data or something like this. But of course, it always depends on the domain and on the use case. Do you guys feel that we can go on to another example that we have mentioned?
Yep, let's go.
So I guess, Artur, then you're next.
Yeah, so I also have an example from the IoT world. We together, three of us, has already faced this category of problems in Visman, but I will use some easier example, at least in my opinion. So let's take an example from my life, actually, from my house. Right now I'm in the middle of implementation of the lights attached to the staircase. So the intention here is to turn on the light when somebody is coming to stairs. So when it's dark and when the movement is sensed, then the lights will turn on, so people can easily and safely walk up the stairs. So in this problem, to solve this problem, we need to have two informations. Yeah, first of all is that somebody is entering the staircase, and the second, it's dark enough so the turning of the lights is required to to allow a safe journey through the staircase. So we have two informations, and in the IoT world, when most of sensors are, for example, Zigbee based, are made in a way that is energy efficient, they are using the asynchronous communication. So only the sensor is sending data to the backend, and backend cannot trigger those sensors to take the reading at this point of time. So we have two inputs. First of all is the movement sensor. Second is the luminescence sensor, and combined those two, we can make a decision on backend if the action of turning on the lights should be started or not. And we can solve that problem in two ways. Yeah, we know already that we can't query the sensors, which would be the strong consistency way. At the moment we want to make a decision, we could query both sensors, get the most up-to-date information about those states, and make a final decision if to turn lights on or not. But in this case, we cannot do it. Yeah, so we're left with a fact that only one information will come first. It's either from the movement sensor or from the luminescence sensor. And for the other one, we will need to wait. And this leads us to another problem, that we cannot wait for another sensor, because this sensor can send next update in 5 seconds, in 15 seconds, or even in 5 minutes. So it's much too late to wait with the decision if to turn on the lights or not, because the person would already leave the staircase and cross it in the darkness. So the only solution that is left, and we also needed to implement it in Visman, is to keep the state of our sensors. So in other words, to base on not the actual information about the real world. Yeah, so we need to assume that the last, for example, luminescence reading, that we can take it even though it's not from this point of time. It's, for example, 10 seconds ago, and we need to trust this information. And this, in most cases, like you, Marek, said in the security, this solves the problem. Yeah, in most real life cases, the circumstances are not that difficult, that this solution will work in 99.9%, but we need to have in our minds keep it in back of our head that there might be situation when the algorithm will behave differently than it is expected to do, just because those assumptions, like working on not the up-to-date information.
But the challenge I see here is just to be sure that the timestamps in the time in the system is consistent. Again, consistent, yeah. Because if you will rely on the timestamps, you have to be sure that the time in the whole system is super synchronized, yeah. Which can be also challenging sometimes.
I must say that in those, at least in my experience, in those local IoT systems, usually timestamp are not used. It's rather a matter of the only timestamp that is registered is when it's received by the backend. So, for example, the sensor, for Zigbee sensor, is not sending you the timestamp; it's sending you the latest reading. And the timestamp you can assign on the moment when it reached the, for example, Home Assistant, as an interpreter of this data. And in these local implementations, usually the infrastructure does not introduce much latency. So I feel that it's not a big problem here, at least. Maybe in big IoT solutions, that are implemented over the internet, when data has to leave your local network, go to the cloud, then be processed by multiple services in the cloud, it might that's true. It might be very difficult and harder to solve.
Yeah, so what you've just mentioned reminded me about one of the Twitter profiles, Internet of S, and I'm not going to follow because kids might be listening. It's like, the cases where my light bulb is not working because of my Wi-Fi is being down, right? So or the internet connection is being down. So these kind of cases are best solved within the home, on the infrastructure inside the home, and not doing the internet connectivity there. There's one on the other subject when it comes to the IoT, and it also comes from the context of Fismon, where we used to work together, and that's about the how the consistency is perceived by the end customers. So the case which we are facing right now, and that's a general case for IoT applications, I would say. I mean, IoT application front ends, is that they are pretty remote from the actual IoT devices installed somewhere at a home. So let's assume the situation that we have a customer who's having an application and he went for shopping, and just before they are coming back, they would like to adjust the temperature at the home so that is going to get warmer before they get back. And there's that time when the customer takes the app and sets the temperature higher or lower, whatever. And the app in this particular moment has to somehow provide feedback to that particular person, right? So usually the customers would like to have the super instant setting experience. So I've just clicked it and it's applied and we're done. But the reality is a little bit more difficult because that change has to be carried from the app via the backend, via a broker solution like an IoT broker solution to the device itself. And then the device has to successfully apply the change, and in some circumstances it may not. So we're having a situation that command coming to the entry point of the system, which is the app, is traversing through the stack, and it eventually reaches the device. Now, if anything goes bad along that line, we are falling out of the consistency, and we are actually inconsistent up to the point at which the device, let's say, it applies the requested change. And then in the context of the IoT, we have a keyword called telemetry, which essentially means sending the device information or the device state back to the cloud. So it's sending out information about itself. So when we are having that command to set the temperature running through the stack to the device, when the device applies the change, it sends that change back over that telemetry channel. And at the end of the telemetry channel, we have the customer application again, which means essentially that we have a full feedback loop from the user via the device back to the user that the change was really applied. Throughout that time, from the time of sending out the command and getting the feedback that the value was really set, we're constantly in an inconsistent state, right? So and this kind of situation is pretty much, I would say, unavoidable in this scenario. So we can't really provide the user the experience that they are going to have instantly and surely in a strong consistency way set the value, because the technology doesn't allow that. So if you have like an IoT broker, which is messaging based, like MQTT for instance, inherently out of the box you're falling into eventual consistency because of that messaging pattern. So sometimes the fact that you are forced to run on like eventual consistency or have inconsistent states comes from the technology or the stack used in order to implement like the communication, for an instance, right?
There is one way to tackle this, which people are doing, which has its own challenges, but can somehow improve the user experience, which is called the optimistic UI. Yeah. So when you trigger the change, you assume it as long as you didn't receive 500, for example, or 400. You basically set it on the UI, and unless the update from the backend will come with different state, it will stay there, and user won't notice the delay. Yeah, so can be tackled somehow. Yeah, that maybe the state isn't like surely consistent, but it looks consistent to the user.
Yeah, the other way I feel like is just, Grzegorz, you mentioned waiting for this confirmation message, which is actually for an example of MQTT is another message sent back from the device to the backend, confirming that this command that you send me is already applied with successfully. But this comes with a cost, and the cost is time. Yeah, because then on the UI you would need the user to wait for the response, which in some cases might take a very long time. Yeah, it's not a second or 2 seconds, because it's already 2, 3, 5 seconds is already annoying to the user that just wants to change something on the, for example, heat pump that he's standing next to, and for him it's how comes that it takes 5 seconds just when I'm standing next to my heating appliance. Yeah, this this application is, and lots of words that I don't want to say here on our podcast. So this is a cost of this, let's say, implementing strong consistency using asynchronous communication. Yeah, the cost is high. But and if you don't want to take that cost, then you need to take a risk. Take a risk and trust part of those system. Yeah, optimistic sending is first of all. Next, you can play with QoS if the application allows you. So there will be parts of the system that, for example, on a failure can retry sending this command. So it will do its best to make the command executed. But there are actually, like you, Gregor, said, no ways to make it quick, make it 100% sure that it will be applied and be immediate. Now it's time for you, if you, our dear listeners, have some experience with eventual strong consistency problems, just let us know, share it with us, write a comment or send us a message. And for now, it's all. Thank you for your time. Bye-bye.
Bye-bye.
Take care. Bye-bye.
That's all for today. Thanks for spending your time with us.
Visit our page on Facebook and Twitter, leave us a comment under the episode, subscribe to the updates, and share it with others.
We would like to hear your feedback so that we can prepare more interesting content for you to enjoy. Hear you next time!